It should be a three to four person on the,
If
get
you had
the
to
outdoor unit
manually
on the
lift it.
rack.
Yeah.
Yeah. We used a skid steer. I mean, I was sweating,
Yeah.
like maybe a little like here.
I just went
Um,
back and did the finger waves like
yeah.
down, up, come forward, stop. That
More
was
back.
my. Hey, everybody, welcome to the Make Trades Great Again podcast. I'm Eric. Andy Mickelson's joined me, and he's in my shop. Look at the
In
background
the
there.
shop. In the Ani shop. Here we are.
I'm also in the shop, but I'm in my podcast room, and we
Yeah.
tried to do this whole thing where, we're standing next to each other, but it was really hard to figure out the sound. We're not sound guys.
All right. It'll work. It's going to work fine.
It's working fine now. I like
Yeah.
the background. You get the lev rack with the
Yeah. It's
logos
got
on
the,
it.
yeah. It's good. It's good.
That's cool. Maybe I should record out there once in a while.
Maybe you should. I don't
Yeah.
know. Might not be a bad idea.
So, so you're in Minnesota and you traveled all the way here
Yeah.
because we just finished yesterday installing a really cool heat pump system.
Right.
What do you think? What did you think of it?
Yeah.
We put in Viessmann's air to water heat pump for a hydronic application.
Yeah. Yeah. It was the, what is it? The Vitocal 100 AW,
Okay.
in the 51078. So what does that give us? If their nomenclature is 51,000 BTUs of cooling and 78,000 BTUs of heating.
Yeah. So a 5-ton
Yeah.
unit,
Yep.
like a dual fan, extra tall, super
Big.
heavy, big outdoor unit.
Yep. Big outdoor unit. Nice looking. It's black.
Yeah. I got
So
a lot of
when
compliments on that on
yeah,
the gram.
yeah, it's pretty cool looking. So monoblock system,
Yep.
which if you've got any experience with that, sometimes throws up some pump sizing issues, as far as like, how far can you go? Do you have to worry about a line set length and things like that,
Right.
from some of their other competitors. And with the monoblock, you kind of eliminate a lot of that. So that was kind of nice, not having to worry about any refrigerant. This one used R32, right out of the package. So we're
Contained in
low
the outdoor unit.
GWP. Yeah.
Yep.
Yep, all in the outdoor. So, yeah, pretty cool system. Super quiet. Which, if anybody reads through the manual and looks at the specs, they're very persistent about the distances and what
Yeah.
the sound quality is, and there's a lot of information about sound in it. And I kind of was, I think you were too, like, is this going to be a little bit noisy? Because I'm going to be honest. I mean, I don't know what it said, max decibel 65 or something like that. And I'm like, I don't know how many that is. Like, what is that?
Yeah, I don't know what 65 dBs means like on paper.
Yeah. Yeah. I mean, you walk around the corner and you'd have a hard time even knowing if the thing was running.
I
Uh,
couldn't the way I could tell if it was running. Now, mind you, this is up obviously after we started up, got up and running. It was a warm day, 40 degrees outside. But the way I could tell it was running when I was, 5-10 feet away was to see the fan spinning. That's it.
yeah.
Like I
Yeah.
didn't know.
Pretty darn quiet.
Right. What I think is really cool about these hydronic air to water systems is that monoblock, like you're saying, all the refrigerants outside. Somebody that doesn't have thinking of plumbers that do work on heating systems, hydronics, boiler piping. Somebody that doesn't have experience with refrigeration piping, refrigerants,
Yep.
all that kind of stuff. You're not vacuuming the system down. You're not charging it. None of that is present because it's all pre-charged, ready to go. You're running water pipe from
Yeah.
from the heating system inside the house. In this case, it's a house, and out to the outdoor unit. It seems a little crazy. There's glycol involved, especially here in Minnesota.
Yep.
Because we'll get way below freezing temperature out there. So we have to protect this, the piping and everything and the equipment. But
Right.
that's what I think is like super exciting about this whole electrification. We're starting to now look at air to water heat pumps for hydronic applications. And it doesn't need to be, at least on the installation side, it doesn't need to be intimidating if you're not already working in that part of the heating field.
Yep. Well, and the interesting thing is that like, shoulder season, when you've got nice warm outdoor temperature, let's say we're 50 degrees or something like that. These
Yeah.
things run like in excess of like 400% efficient. So, 4 or 4.5 COP.
Yep.
It's pretty dang impressive to get that kind of efficiency. In this particular installation, the homeowner had a gas fired boiler to start with. They're on propane, so they're
Yep.
kind of like at that point where, if you're on propane or you're on oil, you're really at the mercy of the market, right? It could get ugly.
For
If you
pricing of
get
the
that,
fuel, you mean?
yeah, if you
Yeah.
get that $5 a gallon for oil again, guess what? Your propane prices go up, your fuel oil prices go up, and you could supplement, with this system if you have the right heat emitters. That's something to be considered. There's not the end all design for everything, but if you've got a moderate temperature emitter system in the house, these things are sweet. You know,
Yeah, let's expand on that. So anybody listening, what we're talking about uh, is low temperature output. Let's call it that. The
yeah,
lower the better, but this thing will
yep,
produce up to 140-degree water,
yep,
which would take care of the, let's be honest, the bulk of modern houses with copper fin tube boilers
yeah,
probably could run on 140 degree water. And I make that statement. I know it's a pretty bold statement. I'm going to qualify it by saying this. It's very rare for me here in Minnesota to run into houses that were built in the 60s and 70s with copper fin tube, early 80s, and not and have only the footage needed per room to heat the space at high temp water, right? There's
yeah,
usually way more baseboard than is needed, which
yeah,
allows us to kind of creep down that water temperature scale. And
right,
so even an emitter like a baseboard that isn't all bashed up and crushed and has good
right,
airflow could probably benefit from this. Not every one of them. It's more
yeah,
suited to in-floor heat,
yep,
um, like a very high performance baseboard, like a
right,
Runtal or a panel radiator, that kind of thing,
yeah,
that would fit right into this. So it's not for everything. I don't think, are you
yep.
going to be running 140 to fan coils and get a lot of heat out of them?
With the right fan coil, yes, but
Yeah.
most of your, on the market fan coils are going to require hotter
Yeah.
water.
155,
Yeah,
160.
yeah,
Yeah.
yeah. If you're running 140 with a 20-degree split, on your hydronic side, you're going to have, 118, 115-degree air coming out, and it's not going to feel incredibly warm blowing around the room.
Right.
So,
I should say this is capable of producing hotter water, because as a standalone system, it has electric
yeah,
resistance element to it on the indoor unit. So there is a box on the
yeah,
wall inside that has the piping connections to it, has all the controls
yeah.
that'll bump your temp up to, what do they say, 160,
165, I think,
65, 68, something like that.
something like that. Yeah. Yeah. And I guess that to bounce back on that too, that same kind of concept, on your air handlers, it's not to say that you can't use this with an air handler, but you need to really be aware of what your air handler is capable of.
Yeah.
Um, because there are, like I said, there are low temp air handlers and fan coils out there that are built, purpose built for low temp.
Yeah.
This market that we're seeing, we're seeing this as it's new technology to us, right?
Right.
This is a budding economy or a budding market in the United States, North America, Canada, where we're starting to see some really cool innovation on low temp emitters,
Yeah.
right? Some panel radiators that have fans built into them. There's some, baseboard, you look at that, like the Smith HE3 and the HE2, those baseboard emitters are purpose built for
Yep.
low temp.
Yep.
And you got to really open your mind up and look at that and go, well, yeah, it's, a fin tube copper radiator or emitter. It doesn't, just because the old school says, well, baseboard runs at 180, doesn't mean it has to run at 180 all the time.
No.
And when you get these purpose built low temp emitters, I mean, that when you pump 180 or 200-degree water through that thing, the output is staggering.
Yeah.
you
Yeah.
know, if you're still running that. So
Right, right. And it'll also do this unit that we put in, the Vitocal, will do domestic hot water with an
yep.
indirect water heater. So you're not doing it, it's
Yep.
not tankless, it's not instant, it's not a like, it doesn't operate like a tankless water heater. You do
No.
have to do storage, and you're not going to get the massive recovery and super high performance out of this for hot water production like you would with a gas boiler connected to an indirect water heater.
Sure, with the higher BTU output. Now, I mean, there is one factor, and I was surprised. So, you and I did this the 5 ton unit here this week.
Yep.
Earlier in the last week, my crew and I we did the little 1.5 ton unit,
Yep.
um, and I was like blown away how fast that thing recovered a 40-gallon indirect. And part of it is that it it's got the loop pump that's built into the indoor unit. So we've got
Okay.
this monoblock outside unit. We've got a supply and return pipe coming from that unit into the indoor unit that's on the wall. So the indoor unit, for just imagination purposes, is about the size of a, oh, I don't know, it's a little bit smaller than like a wall hung tankless water heater, right?
Yeah,
Uh,
I'd say, I think that's a great comparison for just size wise. It's about the size of tankless water heater.
yeah.
Let's just say that.
Yep. So in this Viessmann case, it's got a single circulating pump built into that indoor unit and a three-way mix or a diverting valve that handles our hot water versus space heat. And then that indoor unit is then connected to a buffer tank. And it's surprising. So that circulating pump is variable speed. So the indoor control is looking at supply and return water temperatures and the target, and it's basically ramping up that pump to maintain delta T. Well, in the case of domestic hot water, it was I was surprised at how low it turned the pump down,
To get
right?
a
So we had
ton
a
of heat
massive
transfer.
delta T.
Yeah.
Yeah. And so if you think about that and go, well, what advantages do we have with a big delta T? Well, if we've got moderate outdoor temperatures, we've got heat available. If
Okay.
I've got a nice cold return temp coming into that outdoor monoblock, I can dump a ton of heat pretty easily into that water or into that glycol solution and then return that back at a higher temperature
Yeah.
without as much work, right? So that's really the focus and the basis of a heat pump water heater is to take advantage of that compressor, the refrigerant transfer. We're doing mechanical advantage to compress heat into a glycol solution. And like I said, I was kind of like, well, the small one's 28,000 BTUs. That's less heat capacity than a standard 50-gallon gas water heater.
Yeah. Absolutely.
Uh, so that's a what would you call it? An economy version indoor or tank water heater. And I would say that I didn't time it because we were doing other startup tasks in the process, but I would say it took 45 minutes to heat that tank, the 42 gallon or what is it, 40 EVIB 42.
Okay.
Um,
And you had just filled it with 45-degree water.
yeah. I think it started. I mean, we have our groundwater hasn't cooled yet. So
Okay.
we're running like 53 or 54-degree groundwater.
Makes sense. Yep.
Um, so we went from 54 to 120 in, I would say, 45 minutes. And there was some screw around time in there. Maybe it was a little longer, a little less, give or take. But
Okay.
I was surprised, that it did as well as it did. And I got to give a lot of credit to the fact that it was able to really closely control delta T and deliver heat into that tank super efficiently.
Yeah,
So,
it's a testament. So, back to the install, like just the logistics of it. So this is a project that I started penciling out and trying to fit, trying to find the right application for this heat pump quite a while ago. This was a job
yep,
that I installed the entire hydronic system, entire home, detached garage, house garage, radiant floors, radiant underfloor, low temp, high performance baseboard in the bedroom. So I got heated walls in the showers. I got
yep,
heated floors in bathrooms, things like that. And we had that LP boiler, Viessmann system.
Yep.
We already had the 42-gallon buffer tank in place. That was part of the original system.
Right.
This Vitocal system comes with a buffer tank. And you said it
Yep.
was how many gallons was the buffer
One,
tank that it comes with?
I think we figured it was a 20 gallon.
20 gallon.
Um,
Yeah,
yep.
it's like
It's got 1 inch
75
port
liters or something like
connections.
that. Yeah.
Yep.
And so
Yep.
we didn't use the factory buffer tank that came with this system. So we
Right.
just we were working with Viessmann specifically and directly to get one of these into Minnesota, the first one that I know of in Minnesota, and apply it to an existing system, retrofit basically.
Yep.
And so we had to look at things like you talked about the indoor unit, the IDU. The indoor unit
Yep.
has a built-in pump. And if you're within the parameters of what that pump gives you available head after it's considering the flat plate heat exchanger that's in the outdoor unit, it's considering the piping inside of the indoor unit,
Right.
it gives you 17 feet of head. And you got to size
Yep.
that pipe for 17 feet, stay under 17 feet. You got to size it for, in this particular heat pump, at 12.8 or 12.9 gallons per minute. Okay. And at 45 degrees. And then you have to consider your glycol concentration because of we're using
Right.
glycol. So that what that did is it pushed us up to, because we were about 30 to 35 feet away from the indoor unit to the
Yep.
outdoor unit. We had to look at whether or not we were going to use copper or PEX. And we went
Right.
with oxygen barrier PEX.
Yep.
We went with PEX A. In this particular brand, we used Uponor, but I mean PEX A in that the purposeful. I use both Uponor and Viga, right, and not together. But I mean, I stock fittings for both. I'm tooled up. I've been using both for different reasons for many years, and we went with the PEX A on this because when we did the calculators online,
Yeah.
Andy, do you remember what the difference was? Like, I was going to have to go. If I went with an insert fitting PEX like the Viga PEX
Yep.
B stuff, great system. But if I went
Yeah.
with their system, minimal amount of 90s, I was getting up into like the 20, 25 feet of head for the distance of pipe we were measuring, right?
Yeah. Yep.
Under those gallons per minute flow rates.
Same size pipe.
Same
Yep.
size, yeah, same specs. And then we did it and we were like, well, that's, if we were going to go to have 1.5 PEX and we weren't even able to get down to the, within the specs, we were going to then have to add another pump. Okay.
Right.
And so then there's cost there. And do we want to add another pump? There's a built-in pump. Why can't we just pipe the size, size the piping, size the piping, to fit within this spec. So then we're like, well, I think you had the idea, and let's check out what Uponor says. So we got on
Right.
Uponor's website. This isn't a commercial for Uponor. It's not a commercial against Viga either.
Right.
We went on their site and we did the same specs. We popped it in. I think we even added a couple extra 90s just to be sure that we could do it.
Yep.
And we came back with 1.25 PEX. So
Right.
smaller. So instead of 1.5, where we're going to have to go with Viga, we could
Right.
go down to 1.25. And we were within our specs we needed to be. So that was nice
Yeah.
because what I was ultimately trying to do, I'm just going to be honest with you, I was trying to avoid using copper
Sure.
for an expense. It's
Yep.
if I had to go to copper at 1.25, because 1 inch wasn't going to do it. We're not bending copper around corners and sweeping around big long radiuses like we could with the PEX. Then copper was going to get expensive because we were going to start getting big. And the fittings, it all adds up. Takes more time. It's harder to install.
Yep. Well, and in this particular case, I mean, it was nice that they had an unfinished basement.
Yep.
And they had engineered trusses. Floor truss system. So there was lots of room for activities to get that pipe up in there.
For activities.
That's right. I
I
was able to stick 20-foot lengths of 1.25 PEX through the joists,
through the webbing of the trusses.
And it's open enough that we were able to do some sweeps instead of using a couple of 90s. And what did we end up seeing for a flow loss when we were all done and said with glycol in?
Yeah,
and piped.
Roughly 40% glycol. I measured it when we're done. It was like 42%. So that was pretty close considering I had to add some volume to the system,
Yeah.
right? Um, we were seeing flow rates of like 13, 14 gallons a minute.
Yeah. So we hit
And
our marks.
yeah,
We had more flow than we needed.
yep.
So
Yeah,
that was pretty sweet.
it was sweet. So we went through the wall. You did. So first of all, I didn't do actually any of that supply return piping to the outdoor unit. Andy
Right.
did it all. I was altering the existing piping on the boiler side of the buffer so I
Yep.
could accept I had to redo a little bit of the piping so we had better flow in and out of the buffer tank without just like cobbling it together. I
All
wanted
right.
to do it right. It looks intentional now. I think it turned out great.
Yeah.
Um, we had isolation valves and stuff that would and T's that needed to be added in, so we could add this to the existing system and keep the gas boiler. That's I think the point of this whole conversation, right? In the end, we'll talk
Yep.
about that in a minute. But when you got that installed, you went through the wall from inside the basement. You went out to the outdoor unit. You were still full size 1.25 inches, correct?
Yep.
And then you
Yep. We
transitioned over.
Yeah, what I wanted to do is I wanted to make sure that where we went from the house to the unit, that there was some PEX extending out of the house, mostly just for vibration. So we extended that PEX outside the house. Came out, I don't know, 8 or 9 inches with the 1.25 inches. We transitioned down to 1 inch and then went as quickly as possible into 1 inch copper. And then we ran that 1 inch copper up and into the unit. I was trying to keep the avoid having a bunch of PEX fittings outside just because there wasn't any way to support it.
Yeah.
And so it would have been tough to insulate. It would have kind of moved around. It would have been, may have gotten kind of saggy or droopy or something like that. That would have been not as nice to look at. So,
Well, I think you did actually, I wish this part of it was on video in this podcast, but I think you did a phenomenal job. It looks so clean. It looks so
yeah,
intentional. No extra fittings. That was kind of a point I wanted to make too.
right.
Your supply and return piping, like you said a minute ago, we took a couple long sweeps, kind of go around some corners inside the basement that eliminated fittings, which, like I
Yep.
said earlier, we weren't going to be able to do if we were piping in copper. Um,
Well, and that's interesting. When you get into size on that stuff, and this is what kind of one of the things that we were talking about. At 12 gallons a minute, I think I remember two of the figures, like a 90 in Uponor was like 17 equivalent feet of pipe,
Yeah,
right?
it's nuts.
So you throw 690s in there, and all of a sudden you've got like 100 equivalent feet of pipe.
Yeah,
On the other brand, and it doesn't matter. It doesn't matter what insert or expansion packs. I mean, they were like 27 feet equivalent each.
they
So you
were
throw
big.
two of those or six of those in there, and it's like, holy cow, this we've got to you've got to look at those kinds of things. You can't just say, well, oh, I measured it out. It's 160 feet, from the outside to the inside, supply and return. If you don't count the fittings in there, you're likely going to set yourself up for issues.
Oh,
You
100% you
know,
will. I mean, look, if you're directly on the other side of the wall and you got like 10 feet of piping, that kind of thing.
yeah, what you could have done it in 1 inch.
Yeah. But because we were going 30 feet one direction, so now we've got 60 feet supply
Yeah,
return. We're adding all of this up. We're adding the fittings in. We're doing the calculations for that head loss because we didn't want to add
yeah,
another pipe or reconfigure how this thing or redesign how this thing was have to be piped. So anyway, staying within the parameters of what we were
yeah.
given, it wasn't difficult at all. And to go to 1.25 inch copper or pipe for the tubing, the supply and returns wasn't a huge increasing material cost. It really doesn't take, in my opinion, it doesn't really take any more work to work with 1.25 inch copper versus 1 inch copper, or I mean 1.25 inch PEX versus 1 inch PEX. Would you agree? Like you go
No,
to 1.5 inch, 2 inch, it's a different, it's
sure.
stiffer, it's harder,
Yeah,
fittings and everything are bigger, but
yeah. Well, you had the new Milwaukee M18 inch and a half, 2 inch expander, and that thing is just like dynamite for doing
yeah,
inch and a quarter.
it's super
You
nice.
know,
It's
it was quick.
relatively compact. It's fast.
Yeah,
It's a fast tool.
it's yeah.
Yeah, I liked it.
So
I like it
yep,
too. So then you're also insulating that piping, guys. So like think about
Yep.
like I said earlier, you're not doing refrigeration piping and stuff, which is insulated, but you're
Yep.
insulating this supply and return piping both outside and inside. We're on the
Yep.
north side, so we're not super worried about UV exposure on that small footage of piping that's outside, but we're still going to get
Yep.
that protected. We just didn't really know what we're going to need for fittings and covering and stuff like that. So we've just got the Armaflex, the rubber stuff, Armacell or
Sure.
whatever it is on there right now. But
Yep.
yeah, I mean, what do you think? How do you think the installation went overall? Like logistically, I thought it went well.
Yeah, I think overall, I mean, it was smooth. I mean, we always say this, and I see this, as my crew is expanding their skill set. The more the guy, the more experience you have doing this stuff, the easier it is to, say, hey, I'm going to go jump on this. I'm going to jump. You're going to jump on that, and we're going to meet in the middle, and we're not going to have any issues.
Right.
And this was a classic of that. That mechanical room. There was plenty of room for both of us to work, but it was easier for us to start at two ends, and by the end of the day, we were met in the middle and filling the thing up and firing it up.
Well, and I love that. Yeah, I love that. That's like, so it's so cool to work with you because now we've done it a few times.
Yeah,
Because I've traveled out to you and worked with you, and it's like the highlight for me of the year, right? And it's because I don't get to do projects like that. But this
yeah,
one, as simple as it was another highlight too, because of what you just said. Like you could take calls from your guys while you're working, on your
yep,
AirPod while you're working outside, hooking up the unit outdoors, and doesn't take some massive level of, some expert level of concentration. You're able to, it's pretty straightforward. You're hooking up a supply and a return
yep,
pipe to it,
yep,
a couple of components out there, some nice fitting work, that kind of deal. And I didn't have to, like, for me, now normally I'd be doing something like this alone, right?
right. You're thinking about all of it,
I'm having to do all of it.
right?
I got to start here. Do I start over there? I'm not meeting anybody but me in the middle. And
Right.
so it was so nice to where I had my work cut out for me inside. I had to drain that
Yep.
40-gallon buffer tank down that's full of glycol. We're not getting rid of it, any of this stuff.
Right.
We got to get it taken out, kept clean, put all back together without making a mess so we can tap into the system, redo the little of
Yeah.
that piping. And I didn't have to worry a bit about what was going on the rest of the system. It was so
Right.
nice. So in
Yeah.
my opinion, I'll be completely honest with you. This is a 2-person job.
Yeah, I think so.
I don't think that simply given the size of the 5-ton outdoor unit, this is not something
Yeah.
that one guy is going to do. One gal,
No.
nobody should be doing that given the cost of the equipment, the customer's property, and then the likelihood that you would get injured. This thing weighs, what did
Yeah.
you say the dead weight of this?
411 pounds.
No.
So that's all. I mean, that's pushing. I mean, what two guy? Two. It should be a three to four person on that.
If
Get
you had
the
to
outdoor unit
manually
on the
lift it.
rack.
Yeah.
Yeah, we used a skid steer. I mean, I was sweating.
Yeah.
Like maybe a little, like here.
I just
Um,
back and did the finger waves like
yeah,
down, up, come forward, stop. That
more
was
back. Yeah,
that was,
right.
my wrist was it was a little tight when it
Yeah,
was done. No, it was simple. But you're right. More than a 2-person job to lift that thing up onto a stand. If you
yeah,
had to get, if you're working with a stand to get it up off the ground for snow clearance and stuff like we have to. Yeah, 400 pounds. I don't know that your 2 people are lifting that,
Uh,
to be honest with you.
I mean, this is not an inexpensive piece of equipment.
Not a lot of
I would be nervous
yeah.
for two guys to try and deadlift 400 pounds and step over a stand or something.
Yeah,
Like
maybe if you had the right kind of ground,
maybe
level
shoulder
ground,
straps, you could do it.
I was gonna say, and then
Yep.
hump straps. That's what I call
Hump straps. Yep.
them.
Yep.
So yeah, so then overall, I mean, next steps, we refilled the system, got it purged out. That was easy.
Yeah.
I was blowing relief valves because I didn't have one of the valves open. That was my fault. Seriously, it was just it really
we
wasn't
were
that
both
big a deal.
standing there.
Yeah. Yeah, I guess
it took a little while before somebody said, "Oh, hey, what about that valve?"
Yeah.
Like, oh,
Yeah. But wiring doesn't really get any easier. This thing was you got to
yeah,
run power to the outdoor unit, of course, power to the indoor
yeah,
unit
yeah.
because
Keep in mind that power requirement, indoor and outdoor, they are separate. So it's not like a
two
mini
circuits.
split.
Yep.
Yeah, two circuits. So keep that in mind. And you
Yeah, you're
need
not.
a neutral on the inside.
Yeah, that was interesting. Why is that? Is that because there's that
The
120?
circulator pump.
Yeah.
Yep.
Okay.
Yep.
And it was what was that number 8 wire?
6 on the indoor, I think.
It
I
was
think
6.
that's what they had calculated it out to.
Okay.
50 amp breaker inside outside on that one. Um, so
Not
it's a
small.
no, pretty healthy. It was interesting. So I mean the 50 amp requirement was a question. Like, well, is it really required? I mean, what's the reality? Because when that thing was running at 88 hertz or whatever, or 84 hertz, I guess is what max I saw it at. It was like 11 and 12 amps. It was just nice, gentle load. And I was like, wow, that's pretty cool.
I think it's because the NEC sizes those things like with inrush current calculation or something like that.
Something.
Honestly, I think that's where it comes out with that HVAC, like 115% sizing kind of
Right.
rules and things like that. I don't want to get in deep on that because I honestly don't know
I
that
don't
those
understand it.
parameters inside and out, and I really don't understand it either. Um, the wiring was a bit of a challenge given where it was uh connections on the indoor unit. The outdoor unit
Yeah.
really doesn't get any easier than hooking up an outdoor mini split, this heat pump. Like they're all as simple as it gets outside.
Yeah.
And then so once you get your power, your main power connected, two circuits, your indoor and your outdoor, then you've basically just got some sensor wires and stuff to hook up to it.
Yeah.
Really, there's nothing happening here. We don't have like a wall control. There's no remote or anything like that. And start
No.
thinking about like mini split heads and stuff. There's none of that's going on here. This is
Right.
integrating into a whole centralized heating system.
Yep. Yeah.
You can run it off of like a indoor room sensor, which is, would you say that's kind of, that's really just, Viessmann's really the only one doing that, right?
Yeah. It's basically gives you the ability to have like indoor room feedback,
Yeah.
which is pretty interesting. It helps shift the target water temperature. So
Yeah.
as you approach your room temperature set point, if you will, it starts tapering off the water temp.
Yeah.
The intent is that it never shuts off; it just idles itself down.
To match heat load.
Yeah,
Okay.
yeah,
You can operate it without that, but it is part of the control strategy. Then you've got the ability, like I said earlier, to do domestic hot water. So then you'd have to have an indirect tank for that.
mm-hmm.
You would had a sensor to the tank and you'd run the unit off of that sensor
Yeah,
to enable domestic hot water. You can prioritize domestic hot water. And then you can also, like we're basically using this to maintain a temperature on a buffer tank.
right.
And then once we hit a couple of parameters, whether it runs long enough and doesn't satisfy the temperature needed based off of a heating curve at the buffer tank, we can
Right.
have it enable the gas boiler. And we can also have it enable the gas boiler when it gets to a certain temperature outside. And these things are
Yeah,
parameters you have control over even.
yeah,
Ultimately, my point though is the wiring, like to get this thing like operational for wiring was very simple. You just couple sensors that are going to be needed regardless of your heat. Like if we were using a gas boiler, we're doing the same things. We're connecting
yeah,
the same kind of equipment to it.
yeah. We've got that there. The only other thing I think that, unless I just missed you covering it, was the indoor to outdoor unit wire.
Oh, there's a
Is it?
communication cable. I
Yep.
missed it
There's a
completely.
shielded, like it's 22 gauge, stranded shielded wire that they want.
You have to
I think a
supply that.
twisted
It's field
pair. Yep.
supplied.
Yep. And that connects the indoor unit to the outdoor, and that communicates to the indoor and the outdoor communicate via Modbus, which is nice on the sense that there's a lot of information passed back and forth. And it's kind of cool on the control panel inside. You're able to dial through that control and see, supply and return temperatures in and out of the monoblock. You're able to see EEV valve position. You're able to see supply or discharge pressure and temperature, suction pressure and temperature, liquid line pressure and temperature. And it's really actively monitoring all of that, along with fan RPM and bus voltage and amp draw and all kinds of stuff. So
I'd imagine with that communication, that Modbus like that would be able to monitor all those things. You're looking at it on a screen inside in the indoor unit. You're able to access that information. I imagine it's there so that it's using it for different reasons, but ultimately, wouldn't it be like a safety shutdown? Like if you lost refrigerant or something like that, if you had seen a zero pressure reading at the suction line or something like that, now all of a sudden we're like, it's going to use that as an indication to shut itself down, go into like a lockout mode.
Yeah. Well, and there's some concern on the level of this low GWP, or these not necessarily low GWP, but the AL2 or A2L refrigerants rather. What about this flammable refrigerant? And everybody's kind of there's a lot of false information, I guess, if you will, going around about like, oh, you're running propane in your refrigerant system. And well, it's not propane, but there and there's something to learn there, But with that said, there's also something that we have to take into account. And I hadn't really thought much about it. There on the unit comes with a Calefi air separator, micro bubble separator they show it on the outdoor unit. Yeah. And I thought, well, what if we put that on the inside? We should be able to put that on the inside. And I don't know what the reality of it is, but it is on the discharge of the outdoor unit, right?
Mm-hmm.
And my suspicion is that if that braze plate exchanger were to fail, and we were to leak off, a mildly flammable refrigerant into our glycol solution, is that air separator on the outside there intentionally to vent refrigerant before it's gone into the house and vented out of a buffer tank or some other type of a system separator?
That's how from what I understand it, the way you described it is how I understood them explaining why it's there in the first place. So yeah, I think you're dead on.
Yeah.
I think that's how they were able to get the unit approved, listed, everything like that for installation in North America, because then it didn't require the what's the refrigerant detection system that would shut it down and whatnot for leak detection. Because the only way for it to leak into the house in one way or another would be through that supply and return piping.
Yep.
Just like you explained. I think that was how they got that certification. Ultimately, it's running. We need to we have some kind of like some application challenges on enabling the gas boiler and stuff. We're working with Viessmann on that right now. Yep. I mean, I think it's worth bringing up. This is a new enough system that it's available for anybody to install, but we sort of pushed the, I don't know if pushing the capability, pushing the envelope is the right terminology. What we did is perfectly within its design parameters. We're working kind of outside of where this thing is already been applied. They've got a lot of test cases, a lot of beta sites. They're selling it out in the market right now. It's proven it works. It's ready to go. But most systems are going to be standalone. And I bring all that up because like your system you guys installed in Missoula this last week is a standalone system. It has its electric heating backup built into it. You don't need any more than what it has for that application, right? This application, however, was as far as we understand, might be one of the first or few that are being used with a gas backup system. And so some of the control logic is a little, let's say, unclear right now. And they're working to our buddy Patrick's and the tech support people and whatnot, to the engineers, to their credit. We had these guys on the horn for a better part of our programming time, probably 5, 6 phone calls over the space of a couple
Yeah.
hours
Yeah.
to just kind of clarify some of the questions we had, being that it was new to us and we hadn't experienced what is this
Yeah.
terminology? What does this mean? If we
Right.
say yes or no here, what is it going to do? That kind of thing. So
Yep.
we're working through a little bit of little growing pains, let's call it, and
Yep.
making sure everything is set properly. And we're gonna probably have to revisit this job a little bit just to make a couple tweaks on the programming. That's it. Otherwise, it's heating the house. And I want to wrap this up. Unless I mean I want you to add whatever else too, but I want to say this before. Go ahead.
I was gonna say I have a question for you because
Okay.
I saw this for the first time, this week, right?
Yeah.
You saw it also for the first time this week, and I never asked you this while we were out on site.
Yeah.
What was your initial thought when we like fired that thing up and we were like, "Hey, it's running"? Like, what was going through your mind of like of how it was functioning? Like, uh,
What did I think? Like I was, so my favorite part of a boiler install, boiler putting
yeah,
something new, taking something out old, whatever. That whole application when I turn the heat on and the pipes start getting hot, like there's a part of me after all the couple decades of doing this work where like that's what's exciting to me because it's the whole I did all this work. It was not
yeah,
necessarily easy. Took some time, put thought and knowledge into this to make it work. I followed the directions, all those things. Culminates to that point where that water got hot coming out of the
right,
unit into the buffer tank. And I thought, this is crazy how fast this thing just heated up. Like it was immediate. It makes no
it was,
noise on the inside.
yeah,
There, I could hear the pump running when we opened the door to the indoor unit. It's like a nice swing door on it. I could tell the pump was running simply because, I mean, it's a pump. It makes some
yeah,
noise. It's quiet. Um, my initial thought was like, seems too simple, right? Like
yeah.
we're using a heat pump outside northern Minnesota, by the way.
Yeah.
We have a
41
design.
degrees out.
It's 40 degrees outside, so it's warm, but we have a design temp of negative 24 degrees Fahrenheit. This thing's going to not run down to 24 degrees below zero by any means. But the fact that we can use an outdoor heat pump and pull heat out of that air,
Yeah.
and it was heating up that water fast. Like it got
It was
hot.
fast.
It got hot in
Yeah. And that's
seconds.
40-gallon buffer tank.
Yeah.
It
That
was
was,
it was it was cranking. Yeah.
yeah. That buffer tank is oversized technically for the house itself, but it serves that house so well because there's like 15 zones. So they're micro zones all over the place. And, like bedroom, a bedroom alone is a zone and set up that way in that house because everything's run off like radiant manifolds, the baseboards, things like that. And
Sure.
so you can do that and it works really well. Right. And so like this thing was heating up that buffer tank like immediately.
Yeah.
What was your thoughts?
It's the same. I was baffled. Like I'm like, yeah, this is whatever. It's going out at I don't remember what the tank was. 80. It was like 85 degrees still or
Yeah.
90 degrees when we by the end of the day, right? We
Yeah.
took the glycol out first thing in the morning and it was like 125.
Yeah.
And I was surprised as well. Like and both of them, both of the installs that I've been involved in were like we power it up, watch the thing go through its startup process, and okay, the pump's on, and yeah, okay, and now you see the compressor symbol come on, and I'm like, okay, this is cool. We're watching, it's at 30 hertz or whatever, so whatever that is for percentage of output, and it's like, wait a minute, there's a noticeable difference in temperature,
Yeah.
right? Like that's significant. And I mean, I think the one time remember scrolling through the page, we were holding like a 21-degree split or 22-degree split,
Yeah.
and
Well,
it was just
because
like,
that indoor pump is a
what the heck?
Delta T pump.
Yeah, yeah. So I mean, that's how you recover heat,
Yeah.
right? I mean, that's how you generate heat efficiently, and you only use the amount of power necessary.
It
So
was it was
it was
impressive.
cool to watch that.
Yeah, I wanted to close on just the idea, kind of hinted on it too a second ago, like my thoughts. I'm looking like I'm thinking big picture. There's a lot of a lot of space for a lot of application space for this kind of system in the existing
Yep.
houses that my customers are living in right now. So I
Yep.
can already think like if they want to go on the electric side of things, they want to think about changing their equipment, their fuel source, things like that. Or if they have an electric boiler already,
Yeah.
and you see high operating costs with those. I don't care if you're in Minnesota and we have dual fuel discounts or we have like setback and all this kind of like off peak. We have the ability to, there's a lot of electric boilers out there. And I think like this system could really fit a lot of
Yeah.
those systems. So to me, it was like exciting, not only just to accomplish this install, like that's
Yeah.
obviously fun, and to work with you and Jay Bars from Formation, our Viessmann rep here in
Yep.
Minnesota was with us. Another cool guy, by the way. We didn't even
Yep.
say anything about Jay. I hope he's listening.
Yep.
Thanks, Jay. Just big picture, think about the big, think about the whole country and where boilers are. There's a ton of them
Right.
in the Northeast, right?
Yeah.
And out there, you got people going from fuel oil to maybe propane, or maybe they're looking at heat pumps, or maybe they live in a state where they're like, you're not putting in any new fossil fuel systems.
Yeah.
You're putting in heat pumps. This is going to work just fine. It's going to work for them.
Yeah.
It's going to work.
It's
well.
going to be viable. Yep.
Yeah.
Well, and we're seeing this, in the Missoula area, we're seeing a number of customers that are looking at things and they've been told this for, a couple of years now.
Mm-hmm.
You can't go high efficiency with your baseboards, right? Or you can't do this, or you can't do that. And we're kind of capitalizing on that in the sense that we're saying, well, yes, you can,
Yeah.
because without too much modification, I could come chop out that old, embassy baseboard, right?
Yeah.
And let's put a piece of Smith HE2 in there that's got twice the output, or maybe the same output, but at 135-degree water instead of 180.
Yep.
Or put in some Runtal or a Meissen panel radiator. I mean, there's all kinds of options.
Yeah.
And all of a sudden, we can take this house that was never built for low temperature operation, and with a little modification, we can make it ready for low temp applications. And then the heat pump is just ripe for that. It's not for everybody.
No,
But
it's also not going to fit everybody's budget. I think we need.
No.
I think we need to mention that too.
Yes.
Of course, everybody's costs, the way they run the business, their market, all those things dictate the cost of these things. We
Yep.
usually don't talk about costs here on the podcast because of that. But like this 5-ton unit, kind of retrofit into an existing system. I don't think you're going to be talking to your customer about doing this unless there's a budget in place of like 25,000 plus. You think that's a fair number?
I think that's a fair number.
Yeah.
Yep.
So it's not inexpensive. Equipment costs are at that number. Equipment costs are roughly half.
Yep.
Okay. Because of just what we had to put in. It's
now you got electrical. You got there's some infrastructure stuff that has to be there.
Yep.
And if you're running a house on a already full electrical panel,
you might have to.
You got to run into that too.
Yeah.
Yep.
Yeah. So look, just to acknowledge, I don't want anybody to get hung up on. I don't want to spend any more time than that on it. But and again, we don't usually talk costs, but I think it's worth bringing up. This isn't inexpensive, but it looks to me like it's a pretty cool system, and it doesn't have to be awesome. Cool to be useful, but it's very cool.
Let me throw this out there too. This and just because it's one more thought. One of the things that we're seeing, and it's been hot on my mind this heating season, right? Like as we're entering into heating season, it's November here. One of the things that we do a lot this time of year is preventative maintenance, right? Yeah. So we got a lot of boilers that we do service on. And for the price that we get for annual maintenance, and I'm not making like money hand over fist on annual maintenance, right? I mean, we're trying to keep it fair because I'm telling these customers, hey, this high efficiency boiler is going to save you money. But one of the conversations that comes up, right? If you're not having this conversation, you're not really looking into what this thing's cost. But if you don't factor in annual maintenance into how this heating system how much it costs you a year to produce heat for your home, you're really missing part of it.
Yeah.
And one of the things that we were chit chatting about the other night was, what kind of maintenance is there?
Right.
Right, this heat pump. What kind of maintenance? Wash the outdoor coil.
Yeah, coil, and then I guess verify refrigerant levels like
Yeah, I'm not going to hook you're not going to want to hook gauges up to it, but you could check that from the controller.
yeah. I mean, that's
You
what I
know,
mean. Like you're just going to
yeah,
verify like
yeah.
the
Check
obvious
operation.
at that point. Yeah.
Yeah, check your glycol level. Check your pH.
Yeah, that's
Make
the
sure
beauty
you're.
of electric
It's like,
systems
wow,
too.
that's
Yeah.
pretty cool.
Yeah.
you
Yeah.
know,
It is
I
cool.
was I was thinking that on my electric boiler in my shop the other day.
Mhm.
Um, and I don't remember what the deal was. I turned around, washing my hands, and I turned around, the boiler's hanging on the wall right behind the sink. And I was like, oh, wow, my pressure's a little low. I'm like, huh, I haven't done anything to this boiler in 15 years.
Yeah. Has it been that long since you built your shop?
Dang close. 14 years, something like that. 13
Gosh, it
years.
seems like it was yesterday.
Yeah,
You and I were
I
talking about
know.
that stuff. That's funny.
But and that's, I mean, it was like, wow, that's pretty cool. I mean,
Yeah,
has it
dude.
been more expensive to operate than a gas unit? Maybe. I have natural gas, but on the other hand, the boiler was significantly less expensive, and it's matched exactly to the number of BTUs my shop needs.
Well, like you said,
So
you're not. Yeah, that should be a topic we cover
that should
coming
be a
up.
topic.
Annual maintenance as you add it, amateurize it over time. All right.
Yeah.
Successful install. I want to say on the
Yep.
record, like I've told you already to your face, Andy, but
Yeah.
seriously, thank you for coming to help me do this. It was
Absolutely.
awesome. Thanks to Jay Bars, Formation Sales out of Rogers, Minnesota. They are the Viessmann rep. They happen to also be the Uponor rep and the Axiom rep and like Apollo. They're a
Yeah.
great company. Um, and Jay's not just I don't rely on him just for work. He's a friend. He's just a cool
Yeah.
guy. And
Yeah.
we have so much in common. You and him hit it off right away because
Oh yeah.
we all speak the same language in our interests and
Yeah.
what we're doing on the job and that kind of thing. So that
Yeah.
was really cool. And then, we had good weather. Everything was
Yeah.
just kind of fun. We
Yeah.
didn't do a lot
Just
of
work.
goofing off. We stayed up too
No,
late
it
one
didn't.
night, but
Yeah.
whatever.
Oh, well, there's that.
Shot some videos. They'll be if you're listening to this and you haven't seen the videos, you'll on our social media, on our YouTube for Mechanical Hub, you'll see those coming out soon over on Build Show too. Andy, thank you, man. I appreciate it.
No problem.
Everybody, thank you for listening. Thank you for watching. Give us your feedback. We want it. We are excited to hear what you guys think about our podcast and the things we're doing. Don't forget to hit us over up on the DMs, or you can email us even. Email us at maketradesgreatagain@gmail.com. All right, dude.
All right. Have a good one.
You too. See ya.